composition of trig functions with their own inverses. Another way you could look at this section is this is really inverse trig cancellation rules. And I can never remember if cancellation has one or two L's. But I'm not an English major, so this is what you get. All right. So I said in the very beginning that one of their goals of inverse trig is to be able to cancel out regular trig. And there are some cases where it works and there are some cases where it doesn't. I will go ahead and say that I don't memorize these rules. I just kind of think through things one step at a time. I think through the inside and then through the outside, and I don't really memorize and sit and think about these things here. But some people do like to memorize them and deal with them that way, and that's why we're going to go over them. So the first things first, I want to talk about these guys right here. So as long as, if you have the inverse function on the inside, and as long as the value going into this is a reasonable value, it cancels. And if you look at the unit circle, right, -1, 1, -1, 1, the x values, they go from -1 to 1, right? The x values, they go from -1 to 1. Cosine will never be bigger than 1 or less than -1. It can't be. It has to stay on the unit circle. So what this is saying is, hey, as long as you don't try to like have a point out here that doesn't even exist on the unit circle and try to take cosine inverse of it, as long as the x value you put in makes sense, then you can go ahead and cancel. And it's the same thing with the y value. As long as the y value you put in is between -1 and 1, these two things will cancel and you're left with just this value right here. Remember, sine and cosine range between -1 and 1. So they'll never be bigger than 1 or less than -1. The way that, so if I was writing this out, I could say something like sine of sine inverse of 2/7. This would just, they would cancel. The sine and sine inverse would cancel. This is 2/7 would be the answer there. Sine of sine inverse of 2/7 is 2/7 because 2/7 is between -1 and 1. Same thing here with cosine. I could say cosine of cosine inverse of -1/3. This would be -1/3 because the cosine and the cosine inverse, they cancel. I have 10% battery, so I will work quickly. The tangent inverse on the outside, right down here. Ooh, that's too small of a highlighter. Tangent inverse on the inside, that one will always cancel. That's nice. So it doesn't matter what you have in there. I can do tangent of tan inverse of 728, and that would come out to 728. It would just always cancel. So those are what those rules are. And I'll just put, you know what, delete. Then for these other rules, it's all about what the range of that inverse function is. So this inverse function on the outside is ultimately deciding what the output is. The outside function is ultimately deciding the type of output that comes out. And inverse trig outputs an angle. Inverse trig outputs an angle. I can't say it enough. I know you've heard me say it like 12 times at this point, but it's so, so important. Inverse trig outputs an angle. I know sine inverse only can output angles between -π/2 and π/2. I feel like this highlighter got smaller. So as long as this value in here is between -π/2 and π/2, these things can cancel. So I take sine inverse of sine of pi over 4. Those sines will cancel, and this will be equal to pi over 4. Same thing with cosine. Cosine inverses range. This feels like it got smaller. Why? Hmm. This is cosine inverses range between 0 and pi. So as long as we take something between 0 and pi, so we could do cosine inverse of cosine of 2 pi over 3. These cosines will cancel. You'll be left with just 2 pi over 3. Tangent is the same thing as sine. The range of tan inverse, because that's what these all are, range of sine inverse, range of cosine inverse, range of tan inverse. As long as this input right here is within the output, within the range of tan inverse, they'll cancel. So for this guy, I could have something like tangent, let's give myself more room here. Tangent inverse of tangent of negative pi over 6. This is equal to negative pi over 6. The tangent and the tangent inverse cancel. So sometimes they cancel and sometimes they don't. And you just have to be careful about assuming when and when they don't cancel. Let's look at a few examples here. Arc sine of 2 pi over 3. I'm going to rewrite it as sine inverse of sine of 2 pi over 3. Sine inverse's range is quadrants, well, it's quadrants 4 and 1, but it's between negative pi over 2 and pi over 2, the range of sine inverse. And 2 pi over 3 is not in that range. So I can't just cancel. It's in quadrant 2. So sine inverse and sine can't cancel. There's a few ways you can work your way through it. For me, what I think about, maybe I can scroll. And delete these things here. So here's 2 pi over 3. And we're looking at sine of 2 pi over 3. So this square root of 3 over 2. What I kind of do when I'm looking at these problems, I just say, okay, but I need it to be in this right half of the circle. So if I look, who else has that same y value? Aha, the other pi over 3 angle, the pi over 3 angle that exists in quadrant 1. So sine of 2 pi over 3 is equal to sine of pi over 3. This is useful because I can find angles that work for the function I'm working with. If I scroll further up to this mess of a unit circle we have here, delete. If I were asked something involving, let's say, just like cosine of 5 pi over 4, cosine of 5 pi over 4, so here's 5 pi over 4, cosine is the x value. But if I was doing cosine inverse, of cosine of 5 pi over 4, these couldn't cancel because 5 pi over 4 is not between 0 and pi, and the range is between 0 and pi for cosine inverse. So I would look for the place where this x value is repeated, but still in the right range. So looking all the way up, the other pi over 4 angle, the pi over 4 angle where the x value will be the same is 3 pi over 4. So I could say that cosine of 5 pi over 4 is equal to cosine of 3 pi over 4, which means I could say just delete that, put 3 pi over 4 there, and boom, boom, they cancel. The answer is 3 pi over 4. So that's one way of looking at it. That's the way I personally look at it. But then there's also just kind of going through it step by step. And going through it step by step means, what is sine of 2 pi over 3? Okay, I'll look at the unit circle. Sine of 2 pi over 3 is square root 3 over 2. So sine inverse of square root 3 over 2. This is asking where between negative pi over 2 and pi over 2 is sine equal to square root 3 over 2. And that is at pi over 3. Right, you can scroll up here, right? At pi over 3, if I'm only looking at, it's okay, iPad, you can make it. If I'm only looking at these two quadrants, the place where we can find a y value of square root 3 over 2 is at pi over 3. And that is our answer. This next one, cosine inverse is on the outside, so I know that this is outputting an angle. And I know it needs to obey the range of cosine inverse. The range of cosine inverse is between 0 and pi. 0, pi. 2 pi over 3 is between 0 and pi. So it's in the range of cosine inverse. So these things just cancel. My answer is 2 pi over 3 without doing any additional work. Wham, bam, thank you, ma'am. That's it. You're done with that one. All right, this one is with tan inverse on the inside. So with tan inverse on the inside, we can cancel anything. So when tan inverse is on the inside, I don't have to worry about the range of the inverse trigs. So they always will cancel. Tan, boom. This is equal to, equal to -1. They use cancel, you get -1. And it's because tan of tan inverse always cancels. All right. Last one is cosine of arc cosine of -1/2. So this is cosine of cosine inverse of -1/2. For this one, as long as the value in here is a valid x value, as long as this is between -1 and 1, these two things will cancel. Those things cancel, and you're left with just -1/2. I wish I had put an example on here, and I didn't, so I'm going to put one right down here. Something like sine of sine inverse of 3/2. If you ran into a situation like this, first of all, if you try putting this in your calculator, it'll get mad at you. If you run into a situation like this, it may not appear apparent, but 3/2, that's that is equal to 1.5. So in the inside here, we're saying sine inverse of 1.5, really. This is saying what angle gives a y value of 1.5? Which, here's 1, here's -1. We're not at 1.5. You can't get a y value of 1.5 on here, right? This is not in the domain of the function. So this whole thing, the inside is undefined, and it makes the whole thing undefined. All right. 4% battery left on my iPod, so not so bad. So that's all I have for inverse trig. If you have questions, let me know and take all of this in. Don't forget inverse trig outputs an angle. Don't forget set trig equal to theta, inverse trig equal to theta. Those are big tricks. They'll come in handy, and I will see you in another not another chapter. I'll see you in the next section, 2.2.